Hello guys, welcome back to another video. In today's video, we will build Travel Planner RAG AI agent, where you can input your travel destination, interest, budget, and your travel days. The agent will then look at your previous travel plan histories and then generate a travel plan for the trip. The itinerary will be stored in the text file and also in the database. Excited for the video? Let's get started and code our Travel Planner RAG AI agent. So before building our Travel Planner RAG AI agent, let us understand the workflow and let us understand how we are going to build our Travel Planner RAG AI agent. So first of all, user will input several details like destination, budget, days, interests, and then what our AI agent will do is it will go through database and then search if user has already created a travel planner for the same destination and having the same interest. Then if it finds the travel planner, then it will extract the document and then pass the document and the user input to the LLM. Now, if it doesn't find the travel planner or travel plan, then it will just pass the user's input to the LLM. The LLM will then generate a response. The LLM response will be structured. Then the structured response will be stored in the text file, will also be stored in the console, and the response will also be converted to embeddings and then stored in our vector database. So let us open our Visual Studio Code and code our Travel Planner RAG AI agent. So after opening Visual Studio Code, what I have done is I generate my API keys and other credentials and I have stored in .env file. My .env file looks something like this and these are the fields. First of all, I need to generate HuggingFace API key. I need to generate Supabase URL, I need to generate Supabase key, and then finally I need to generate Gemini API key. Now, how to generate these API keys and credentials? To generate these keys and API credentials, I will provide you all the links in the description. Now, if you open the first link, which is the Hugging Face, you will land up in this page and you can click this create new token and then you will be able to create new API key for Hugging Face. Similarly, if you click the second link in the description, you will land up in Supabase dashboard. From here, you can create your Supabase URL and Supabase key. Similarly, to get Gemini API key, click the link in the description. You will land up in this page. You can click this button where you can create Gemini API key. Now let's come back to our Visual Studio Code. Now what we need to do is we need to install several dependencies. So let us open our terminal. Let me clear my previous terminal. Let me close my side nav and let's install required dependencies. So first of all, what I need is I need Hugging Face inference to create embeddings. So let us install Hugging Face inference. So Hugging Face /inference. Now, second thing I need is several LangChain dependencies. First one I need is LangChain community. Second thing I need is LangChain core. Third I need is we're going to be using Google Gen AI wrapper from LangChain because the LLM that we'll be using is Google Gemini. So let us install LangChain /Google-Gen AI. Now another thing we need is the database that we'll be using is Supabase. So we also need to install Supabase. So Supabase /Supabase-js. Now another thing we need is readline sync because to get the input from the user, we'll be using readline sync dependency. So let's also install readline sync. So let us install our dependencies and I'll be back when this is completed. Okay, took a little while to install the dependencies, but my dependencies have been installed. If you need more dependencies, we can come and install them when needed. So let us come to our package.json. We can see that all the dependencies have been installed. Let us do one more thing. Let us set type to module. Let us save our package.json and close it. Now let us create index.js. So this will be the file where we'll be coding our AI agent. So first of all, what we need to do is we need user's input. So user's input. So to ask for user input, we need readline sync. So let us import that. So import readline sync from readline sync. So let us ask for user input. So what we'll be asking as user input is, first of all, we'll be asking location, days, interest, and budget. So let us ask each of these inputs. So first of all, we need location. So read line sync dot question, and let us ask for destination. Second thing, let us ask days. So read line sync dot question, and we need days. So third input we need is interests. So const interests, read line sync dot question, interests. So fourth thing and the last thing we need is budget. So budget equals to read line sync dot question budget. So okay, these are the user input that we need. Now what we need to do is we need to set up Supabase client. So we need to set up client to interact with the Supabase. But first of all, before setting up our client, we need to configure our Supabase. So let us open our browser. Let us go to the Supabase dashboard. Now to configure our Supabase, what we need is we need a SQL script. So let us open new tab and let us search for Supabase LangChain. The first link, let us click this first link. I'll also provide this link in the description box. Under SQL tab, you'll find this SQL script. So basically what this SQL script does is it will create pgvector extension. It will create a table called document, and also it will create a function called match documents, which will retrieve matching embeddings from the vector database. So let us copy this script and come to our Supabase dashboard. Now let us open our site navigation bar in the Supabase and then click SQL editor. Now I have already run this SQL script previously, so I'll clear this and run it again. But one thing to note is that in LangChain Supabase docs, 1536 is the dimension that is created by OpenAI. But in our case, we are using HuggingFace. So if you search for HuggingFace embedding dimensions, the model that we'll be using creates 384 dimensions. So we need to edit this 1536 to 384 dimensions, and similarly under match documents, also edit the dimensions to 384. Now run your SQL script. In my case, it should throw error because I have already run this script previously. You need to run the script. Yes, in my case, I have already created extension vector, so it is showing error, but in your case, it should run fine. So when you run your script, it should show success, no rows returned. And then when you go on to table editor, you should see a table created called documents. So document contains several columns. First column is integer, which is in the format of integer. And the second column is context, where we store text data. Now third column is metadata, where we store JSON data. And the last column is embedding, where we store our vector embeddings. So let us come back to our Visual Studio Code and let's continue coding our AI agent. So let us create our Supabase client. So currently what we're doing is we are setting up Supabase. So Supabase setup. So let us create our client. So we are creating client because we need to communicate with Supabase. So we have a method called create client, and create client comes from Supabase/Supabase-JS. So we need to pass several things to create client parameter. First thing we need to pass is the Supabase URL, and the second parameter is Supabase key. So let's pass them. So process.env.supabase URL. So this is something that we have stored in our .env file. So another thing we need to pass is process.env.supabase key. So currently, to access the env file Supabase URL and Supabase key, we need to set up and load our env file. So to do that, let us import load env file from process. So import load env file from process, and let us call this method load env file. So after calling this method, now we should get access to Supabase URL and Supabase key. So we have set up our Supabase client. Now what we need to do is we need to set up HuggingFace Inference Embeddings. So let us create a new instance of HuggingFace Inference Embeddings. So to create new inference, we'll do new HuggingFace Inference Embeddings, and we need to pass certain parameters, and the parameters are API key. So to access the API key, we again need to access from env file. So process.env.HuggingFace API key. And the second parameter we need to pass is the model. So the model we'll be using is sentence-transformers and /all and -mini lm-l6 version 2. So this is the model we'll be using. And also we have passed API key. So we have created our HuggingFace Inference Embedding instance, and let us store this instance in the variable called embeddings. So okay, we have set up our embeddings. Now what we need to do is we need to create Supabase vector store instance. So let us create Supabase vector store instance. Now to create Supabase vector store instance, we need to create instance of Supabase vector store. So Supabase vector store comes from LangChain/community/vector-stores/Supabase. And again, in our Supabase vector store, we need to pass several parameters. First parameter we need to pass is our embeddings that we just created. And secondly, we need to pass an object, and we need to pass client, which is our Supabase client. And also we need to pass table name. So table name is something that we just created. Our table is documents. So table name is documents. And similarly, we need to pass query name. So our query name is, so if you come to LangChain Supabase documentation, the query that we created is match documents. So basically this query is responsible to retrieve matching documents. So in our case, the query name is match documents. So we have created instance of Supabase vector store, and let us store this in the variable const vector store. So okay, now we need to create retriever because we want to retrieve similar embeddings or similar documents from our Supabase. So we need to create retriever. To create retriever, we need to access vector store, and when we add period, we can see several methods. We need to call as retriever method. So this method will retrieve similar embeddings from the vector database, and let us store retriever in the variable called retriever. So now what we can do is we can invoke this retriever. We can pass certain query and then retrieve the matching embeddings from our database. So what we can do is, now let us retrieve similar tips, or let us write code to retrieve similar tips. So let us create a query because to our retriever we need to pass query. So let us prepare our query. So what we want to retrieve from the database is, we want to retrieve travel memories about location. So location is the location that is provided by the user. We ask for location input, and the same location we provide in our query, with interests in interests. Okay, so what we are telling is that we need travel memories about the same location and with the same interest. So if it finds this matching query, then it will retrieve from the database, and then it will provide to us the documents. So let us actually invoke our retriever. So we will store the documents in previous strips and await retriever dot, we need to invoke the retriever and pass in the query. So we have coded a lot. Now let us console.log previous strips and let us see what we get from the database. So currently we should get nothing from the database because we have just set our database and we don't have any previous strips. which means that we have not created any plan for our trips. But again, let us see what we get. So previous trips. So save this. Now open your terminal. So let us clear our terminal and let us run index.js. Okay, there's a typo, node index.js. So it asks for destination. Let us provide a destination. Let us provide days. Let us provide interest, sports. Okay, let me provide sports, and the budget I can provide 1200. It should retrieve something or nothing. So okay, you can see it retrieves empty array, which means we haven't created any travel plan before, so that is why it retrieves empty array. But when we create our travel plan, it should retrieve previous matching data. So we have created a code where we invoke retriever and then retrieve similar trips. Now let us create prompt templates. So why we create prompt templates is that we want to send this prompt to our LLM. So to send prompt to our LLM, we need to create a prompt. So that's what we are going to do now. So let us create prompt. So const prompt equals to, we need to create prompt template. So we create prompt template. So prompt template comes from LangChain /core/prompts. Now to create prompt template, we need from template method, and then I will use backticks and then provide my prompt right here. So okay, this is the prompt that I'll be providing. The prompt is, you are a world-class AI travel planner. Here are the past related trips the user has taken, and we'll provide the memory. So basically this memory will be something that we get from previous trips. And then what we need to do is now create a brand new personalized itinerary from the location, what we provide, days, interest, budget, and then we want our LLM to plan each day, morning, afternoon, and evening, and also include food tips, travel facts, and end with a travel code. So one thing that we missed is that this retriever retrieves documents. When it finds the matching embeddings, it will retrieve documents, and they are in document format. So to convert that into plain text, what we need to do is we can access the previous trips, map over it, and then for each document there will be page content, and then we'll join each page content according to \n. So I will show you how our previous trips looks like when you have travel plan, but for now we do this just for the formatting. So let us store this in variable previous context. So const previous context, and this string we want to pass in the memory. So now let us create our LLM. We haven't created our LLM. We created prompt. Now we want to pass prompt to our LLM. So let us create our LLM. Now again, the LLM that we'll be using is Google Gemini. ChatGPT could be used, but in my case, I have already used it too many times. I don't have more credits, so I'm using Gemini. In your case, you can use ChatGPT or even other LLMs. In this case, we'll be using Google Gemini. So let us create new instance of Chat Google Generative AI. And here we need to pass several parameters. First one is API key. So let us access this from our env file, the env.gemini API key. Also, we need to specify the model that we'll be using. The model we'll be using is Gemini 1.5 Flash. And also let us specify the temperature. So we can set it as 0.8. So now we have set up our LLM, we have our prompt. Now next thing, most important thing in a LangChain is to create a chain. So let us create our chain. So first of all, we want our prompt. So we want to pipe prompt to LLM because we want to pass prompt to LLM. And then LLM will give us or respond a document. So we need to convert that document to plain text. So again, we need to pipe string output parser. So here we create a new instance of string output parser, and what will this do is that it will change our document to text format. So now what we need to do is we need to invoke this chain and pass these parameters. So let us invoke this chain. So await chain dot invoke, and we need to pass the data. So first of all, we need to pass memory. So what is memory? Memory is something that we just created here. So memory is the previous context that we retrieve from the database. So in our case, we don't have anything because we just created it. So what we want to do is, if there is previous context, pass the previous context, and if there is no previous context, pass none. And another thing we need to pass is location, days, another thing is interest, and we also need to pass budget. So these are the things that we need to pass. Okay, now let us store the result in a variable result. Now what we want to do is, okay, let us see how result looks like. Let us console.log this out, and then we'll save in text file and in the database. So let us save this. Let us open our terminal and clear the previous code, and then let us run node index.js. So let us provide our destination, Italy. So 2 days, interest is, let's provide eating, budget 1200. So okay, we can see that we're getting good response from Gemini, and this is actually a good itinerary. So we get for day 1, for day 2. So okay, you can see we have interest as eating, and it plans my day by giving me certain sites to visit for eating. So okay, it planned day 2, take a high-speed train from Rome to Florence, check into a hotel near Dumno. Oh wow, this is good. So now let us carry further on and let us store our response in a file. So let us create a file name. So I want my file name to be itinerary underscore. I want to store that with the location. Okay, so we should use backticks. So I want my file name to be itinerary underscore location underscore current date. So in this case, so by doing this, we have unique text files. So now what I want to do is, I want to write the file. So to write the file, what I need to do is, I need to import file system. So let us come to the top and import file system. So import fs from fs. Now let us write this file name. Let us create this file, and let us write content to this file. So fs dot write file sync or write file sync, and the file name is going to be file name, and we'll be passing the result that we get from the LLM. So let us also console.log this out to see the response in the console. So let us format this \n and your personalized itinerary, and we want in the next line. So let us also console.log result. And let us also write a console.log to indicate that the file has been saved to file name. So we need to use backticks. So okay, looks good. Now one last thing that we need to do is, we need to store that trip information to the database, because next time when we generate trip plan for the same location, we need to retrieve the embedding from the Supabase vector store, and we need to plan our trip by looking at the previous trip. So let us create Supabase vector store, or use Supabase vector store. So we need to await Supabase vector store dot from text, because currently we have converted LLM response to text. So from text method, we need to pass result, because our Supabase vector store expects array, so that is why we're using array. And also we need to pass location and interest, because next time when we create a new plan, we need location and interest. So interest, and next thing what we need to pass is we need to pass. So okay, we create our embeddings, and then we need to pass an object wherein we need to pass client, and the second thing we need to pass is table name. So in our case, the table name is documents, and also we need to pass query name. So the query name in our case is match documents. Okay, so this is all. So we have stored our embedding in vector database. We will also store the response in a text file. So let us test our AI agent. Let us see if it works perfectly as we expect or not. So what I want to do is, now let us open our terminal. So okay, here I open my terminal. Now let us run our index.js file. Index.js. So now it should ask me certain inputs. The first input is destination. So let us provide the destination. So let us provide Germany this time. The days is, I want 3 days. Interest, my interest is food, sports. And then let me specify the budget. So 2300. So now what should happen is that my Gemini should give me a nice response, giving me full plan. Okay, so here we get the output, but what we expect is, okay, so the text file was also created, and also what should happen is that my data should be stored in the database. First, let's check the text file. Okay, so we can see the text file is created. It has planned me the day 1. It has also planned for day 2 and for day 3. So it estimates my total budget to be 750. Okay, so it's a very detailed trip planner. Now let us check our Supabase and let us see if, okay, we can see that in our Supabase the embeddings were also created and it was stored. So now let us test it one more time. So now what should happen is that my previous context should get me the previous trip, and in memory it should now create a new trip based on that memory. So let us create a new trip. Let us create a new trip planner. So let us run our node index.js, and let us set our travel to Germany again, and let us set a day to 4 days, and food and budget should be 2300. So now what should happen is that it should extract my previous trip planner, and then it should plan my next trip according to that. So okay, now let us see in the text file. It has created a new text file. So which one is my latest file? So the latest file is 90. Okay, this is the latest file. So it has created me the itinerary. So okay, it has created a very well structured itinerary. So I hope you like this video. I hope you understood how to create RAG AI agent. So my job was not just to teach you how to build travel planner RAG AI agent, but to teach you how to create any RAG AI agent of your choice. I hope you learned that, and see you in the next video. Please like, comment and subscribe, and also I'll provide you the code and all the resources in the description. See you in the next video.